Hello everybody, my name is Alex. I'm the lab manager in Amsterdam, and thank you very much for having us here. We are very fortunate to have our FabLab situated in the oldest non-religion building in the city, and it has been a very busy place. There are thousands of people visited us. We run 2 open days. Every Tuesday and Thursday everybody's welcome to do whatever they want, and we help them to do that. And what you see here behind me, beside the city, is a little poetry project we did. We collected leaves around the building, and we pressed them and dried them, and we laser cutted some poetry in it, and then we put it back on the street in the hope that people can find it. And as Mark told you very nicely, the framework, how we operate the FabLab in Amsterdam, that allows me to zoom in more for what we are actually doing, some of the nice projects. So here you go, here's the building, like the entire first floor is now FabLab Amsterdam and Biolaboratory. And it's situated here in the very center of Amsterdam. So if you come with the train, you just have actually a 5 minutes walk and you're there. I think it's very important to create a bus so many people find us. And this is how it looks inside, like some time ago. And this is how it looked inside 300 years ago. And so, well, about the WAF Society, of course, which is the host of the FabLab Amsterdam, one of our approaches, which we are well known for, is the approach of users as designers, which means whatever we do, whether it's a piece of software or hardware, we are getting in touch with the end user at the very first stage, and then we go with feedback procedure back and forth until we reach what we actually wanted. So we make sure the people who are using our products, they really love it. They don't get stuck with user manuals and stuff. And maybe one of the most promising collaborative projects we do, as Mark already mentioned, is together with HON FabLab, the low-cost prosthesis, which I think is really like what I call design that matters. So we're trying to do prosthesis made from local material, which is very affordable basically for everyone, using the FabLab methodology. And then maybe the most important part of the whole prosthesis is we want to create a new mindset, which is that you have to realize that even in the Western world, people who are using prosthesis, they are totally dependent on orthopedic doctors. And we think that if you use a prosthesis 24/7, you are actually the specialist, because you can tell me exactly, like, it hurts here, or I have a problem when I roll off the curve, or whatever, things like that. So, and this is not even, imagine, it's not even happening in the Western world. And so we are incorporating this in our approach. And of course, since we are not orthopedics and so on, we collaborate with real specialists like Professor Bert Otten, which is one of the big gurus in the Netherlands of neuromechanics and prosthetics. And so we try just from scratch, actually, you see, like local wood together with polyurethane resin. We made some tests, and it's actually working quite well. And another more complicated thing is the connector, which you need here and here to adjust this 360 degrees and this as well. So we started to do 3D prints, how we could design this, that you can adjust it very easy. We think about adjustable, that you buy a bicycle and you adjust the saddle, that you can buy bike in the perfect, most efficient way. And so we managed, here we got it. So this is all basically local material, and like the 2 little spots you see there, if you go them, you take them up, you can adjust and put them down. Very easy, but yet not tested. So now it's going to the university, will be tested on the pressure machine and elasticity and so on. And once we have that, we can do a second iteration, and then hopefully we can finally adjust it by the patient. So that's the stuff we have done in Amsterdam and in Vic. But while we were busy with feed design and connectors, my colleagues from HON in Jakarta tried like a traditional method, which you probably are familiar with, which is bamboo coiling. Trying to make like, could we make a socket, is it efficient, and so on. And well, it looks promising and it's very beautiful outside, but yet it's too rough inside. It would hurt you when you walk. So we stepped over on another principle. Then another thing is, of course, we use bamboo rod instead of precision aluminum, way cheaper, and there's enough in this country. And another thing is, we, like a year ago, we started to try to combine new composites, because actually when I was in Georgia last year, they confronted me with this beautiful natural fiber, like coconut fiber, pineapple fiber, banana bark. And so we were starting to try, like, could we combine these fibers with a kind of binder, whatever binder. I mean, I would prefer a natural one, but we couldn't find one yet. So we used polyurethane with pineapple fiber, and it's a surprisingly interesting composite that looks like this, and that's not optimized yet. We should do some other iteration, but it's breathable and it's precise. So we may have gold in our hands here, and I'm really looking forward to investigate there. But you have to see, like, it's very complicated, and it has to be really stable. So before we will try to fit it on a user. And then, of course, this is our typical feedback sessions with the experts, where we show them what we do, how we do it, and they give us feedback what we could do better. And this is another phenomenon which I really like. It's like what we call the knee walker, and what we do with it is, like, we use it for two things. That we want to let you know how it is to walk with a prosthesis, so you can get more insight in that. And then another thing is that we are trying it out on. We are testing our own prototypes before we testing it by the actual user. So far about the prosthesis project, but of course, like, medical devices is not all we do, like, because in Amsterdam there's a huge community of artists and designers and so on. So what I was really enjoying the last few years is collaborative product design. So you design something together. And I only have the time to show you one project we did, which is this little football table, which I designed in a way that if you make this, you go through all the steps what you can do in a FabLab, like laser cutting, 3D milling, 2D milling, electronics, and so on. And I prepared a little movie for you that you can see some processes with it. Whole concept of the soccer table a little bit further, and make it really our own thing, and very importantly, make it open source. Good learning project, since you go through all kinds of digital fabrication methods.
Your camera in it, the electronic scoring system, you get sensors, so everything is interactive and automatic. Something more sexy, like something that is nicer to see than just LEDs.
Okay, so you get the idea. One other thing I wanted to tell you about is that actually the last 5 years running the FabLab Amsterdam, I've seen many of this joinery in the lab. And I mean, you're architecture students, you know a lot about joinery, I think, and you study. So there's nothing really wrong about that, but if you look at these guys, these are proper Japanese wood joinery from the medieval times. These guys are ancestors, they didn't have any machine, yet the joinery itself is far more sophisticated what we do in the FabLab. So I really thought it can't be right that, that we have digital precision nowadays, but we make actually poorer joinery than our ancestors did by hand. So, and that's why I thought it's time to look back as well, and not only forwards with 3D printing and all that structural stuff, which is great, but we should not lose our old stuff, which is very, very valuable, and actually I see it in all this country as well. So we created the Maker Skill, which should connect the old craftsmanship with digital fabrication and with biotechnology. Because I believe myself, if you connect all these together, then you got the real stuff. And let me give you two examples of it. Like for instance, this is a device you don't see in Fab Labs normally, which is a simple steam engine, steam bending wood. So let's combine that. So if you see that this is a little sheet of veneer wood that we laser cutted the pattern in it, then we cooked it, and then you can bend it like this. Let it dry, and you have a beautiful structure. And all you need is like a box with a steam engine, and then you can go. I mean, look at all this nice 50s joinery. They're not joinery, but furniture, I want to say, like Charles and Ray Eames, these beautiful molded chairs. We can all do this with this technology, which is, I find really exciting because it opens a completely new door in the design world. Then another more sophisticated project we have done, we actually just finished in June, was a dining table, which I wanted to create with a friend of mine, also collaborative together, to show the connection between craftsmanship and digital fabrication. So in Germany I found this amazing big plates. This is almost real size. There was like 1 meter by 85, 60 millimeter thing, massive solid wood, beautiful stuff. So we created, we used Rhino to make like old school fashion Japanese wood joints. And my friend was so good who carved it out in like about 2 weeks. So we just profiled the shapes of the construction, and he did all the rest with Japanese saws and chisels. It's really, really nice. And at the meantime, I machined the whole tops completely, made butterfly connections with the machine, with digital precision. And then afterwards, a lot of surface finishing, which is also something that is disappearing because we don't have time anymore, and we don't pay time anymore. But this surface finishing took me 3 weeks. It was like oiling, sanding, but it's really worked because now the table, this is in my home, the table is totally sealed and it's beautiful, and it gives you like 300 years Swiss guarantee. So it will survive me big time. And so my last message to you is like, there's a lot of talk about Fab Labs, and there's a lot of Fab Labs in the world, and that's amazing. But a lot of people always talk about machines and materials and invest in machines, materials, and in venues, but not in people. But it's the people who make the Fab Lab the great place. Actually, you who come and give me all the problems I have to solve every week. That makes it really the great space. Thank you.